Hi, in this video, I will be showing you problem number 12 of chapter 7, section 3. Evaluate the integral 0 through 4 dt over square root of 16 plus t squared. So we will be using trigonometric substitution here because the integrand, if it has an expression of radical expression, something looking like the table, then we are going to use the appropriate substitution like shown in this table. Refer your notes for theta restriction in each case and also the trigonometric identity that we will be using. So the problem has a denominator square root of 16 plus t squared, so which resembles the second one. So here a square is 16. Instead of x square, we are using the variable t square. So let's make the substitution. T equals 4 tan theta. So dt would be 4 secant square theta d theta. So it's a good idea to change the limits as well. So t equal to the lower limit, which is 0. So 4 tan theta will be equal to 0, or tan theta would be equal to 0, which means theta equal to 0. So we have to actually figure out what the variable, what the new limits for theta are. Theta equal to 0. So for the upper limit, just 4 here, so t equal to 4. So 4 tan theta equal to 4, or tan theta equal to 1, or theta equal to pi by 4. So for the new limits for theta would be 0 and pi by 4. So I'm going to call the original integral given in the problem as I equal to integral. The new limits are 0 through pi by 4. Then we have 1 over square root of 16 plus t square, which is square of this, which is 16 tan square theta. And then we have dt, which is 4 secant square theta d theta. The dt changes to 4 secant square theta d theta. So now I is integral 0 through pi by 4, 1 over, so 16 is common, 1 plus tan square, everything within the radical, 4 secant square theta d theta. So I is integral 0 through pi by 4. Numerator is 4 secant square. Denominator is square root of 16, which is a 4. 1 plus tan square, Pythagorean identity, is secant square. That is within the radical. So if we take square root of secant square, that will be secant theta d theta. So it is integral 0 through pi by 4, secant square over secant, that will be a secant theta d theta. Integral of secant is ln of absolute secant theta plus tan theta. This has to be evaluated between the limit 0 and pi by 4. So the value of this expression at the upper limit, ln of absolute secant pi by 4 plus tan pi by 4 minus ln of secant 0 plus tan 0. So it will be ln of secant pi by 4 is reciprocal of cosine pi by 4, so which will be a root 2. Tan pi by 4 is 1 minus ln of secant 0, which is 1, tan 0, which is 0. We don't write this absolute value here because all these values of the argument of ln are all more than 1, so it's going to be positive. So there is no need to put the absolute sign here. And ln of 1 is 0. So we get ln of root 2 plus 1. Hope this video helped.